Hey, what up, everybody? Welcome back, you IB Math SL1 fans. Hope everybody's enjoying the sunshine lately. But I'm not here to talk about that. I'm not here to talk about the weather. I'm going to talk about exact trigonometric values in the unit circle. Or, I thought that title was a little wordy. We're just going to say the title of today's lesson is Getting Triggy with It. Decided to go with the Will Smith reference over the classic. It's triggy. It's triggy to rock a rhyme, to rock a tangent or cosine, something like that. There's lots of YouTube stuff about all that. But you guys, the unit circle, exact trig values. It's one of my all-time favorite topics. So let's just jump into it. I assume that from Mr. Street's lesson, you guys learned about sine and cosine being like the heights and bases of triangles in the unit circle. So I just want to start with an example. Let's say you were asked to find the sine, cosine, and tangent. The old Oxford comma right there. Oh, that's not how you spell tangent, Jolly. Tan of 2 pi over 3. So we have to find sine of 2 pi over 3, cosine of 2 pi over 3, and tangent of 2 pi over 3. Not sin, cos, and tan. Sine, cosine, and tangent. When people come up and say, Mr. Jelly, I can't find the sin of 2 pi over 3, I'm like, what are you talking about? Sine of 2 pi over 3. You guys, with every single one of these problems, I always draw a fresh unit circle. I've seen people that keep like a unit circle by their side that's all filled out with all the values, and I think this is the wrong approach. It shouldn't be like a having your notes with you sort of thing. It should be just you understand special right triangles and how to draw a fresh one every time. So 2 pi over 3, we first have to figure out where that is on the circle. So not too bad for Apple Pencil. I apologize for my handwriting once again. You guys, here's 0. Here's pi over 2. Here's pi. Here's 3 pi over 2. And 2 pi all the way back around. Once again, we're not using degrees from here on out. It's all radians all the time, baby. So 2 pi over 3. You guys, pi over 3 is the same thing as 60 degrees. So that's right about here on the unit circle. So if you go another 60 degrees, that's right here. This is the spot for 2 pi over 3. So if you draw your triangle, connect it to the origin, drop a line down to the x-axis, put your right angle in there, boom, there's your triangle. Now, at this point, you guys should be comfortable with reference angles. So you guys, if 2 pi over 3 is the same thing as 120 degrees, that means that your reference angle right here is 60 degrees. Now, directly across from a 60 degrees is a, what, root 3 over 2. Now, if that wasn't locked and loaded, if you're not like, oh yeah, across from the 60 degrees is root 3 over 2, you need to pause this video, go back to your special right triangles, put them on a flashcard. You need to have the 45, 45, 90 and the 30, 60, 90 just like the back of your hand. You can pull them out at any time. You don't have to look it up. You just have them locked and loaded. So across from the 60 degrees is root 3 over 2. And then across, like the 30 degrees is up top here. So across from that is your 1/2. Now, the way I've written my diagram, it's kind of not completely correct. And the problem, let's use a highlighter. Let's use a red highlighter, orangish, is this guy right here. I realize in geometry, you can't have negative sides, that should be, a positive side value. But now that we're rooted in this like XY coordinate graph, that is in the negative X direction. So I'll highlight again this side right here. Try to zoom in. This side is a negative X value. So you need to change this to a negative 1/2. Now, the root 3 over 2 is totally fine because that's in a positive y direction. So the root 3 over 2 can just chill. It's positive. but the negative 1/2, the x direction, is in the negative zone because it's to the left of the y-axis is another way to think of that. Oh my god, there's so much pollen in the air. It's coming directly towards me. Never mind, I'll survive. So we've got our unit circle. We've got our 30, 60, 90 inscribed in the unit circle. Now, you guys, the height of that triangle is the sine value. So part of, let's do this in purple, my answer is that sine of 2 pi over 3 is going to be equal to, let's use a purple highlighter, this guy right here, the height of the triangle, root 3 over 2. So boom, there's the first part of the question. Sine of 2 pi over 3 is root 3 over 2. The cosine is the base of the triangle. So let's swap colors here. Let's go red this time. Sine of 2 pi over 3 is equal to the base of that triangle, which is negative 1/2. Once again, the base of the triangle is right here, negative 1/2. Now, the tangent of this is slightly tricky because you can think of it a couple different ways. You can think of tangent as opposite over adjacent, the old SOHCAHTOA version of tangent. And you can do that by having the opposite side be the root 3 over 2, right here. Oh, so many colors of highlighters. And the adjacent side is right here, the negative 1/2. So, yeah, let's just go with the opposite over adjacent version of tangent. So if I were to do that, let's do blue. That means tangent of 2 pi over 3 is going to be equal to opposite side, which is root 3 over 2, divided by the adjacent side, which is negative 1/2. Now, if you are dividing fractions, you have to do the old multi-flip. So that means this is all equal to the top fraction stays the same, root 3 over 2, but then you have to multiply by the bottom fraction upside down. So this is 2 over negative 1. The 2's cancel out. Boom. Our answer is negative root 3. So that means tangent of 2 pi over 3 is equal to negative root 3. Let's highlight all of our final answers. I just love the highlight feature, you guys. What color do we want? Yellow? Okay. So the problem said, find sine, cosine, and tangent of 2 pi over 3. So here's sine of 2 pi over 3 is root 3 over 2. It's the height of the triangle. Oh, you guys, I made a mistake. You didn't correct me. You guys, you should have said something. That mistake is on the second one. This was supposed to be oh, no. I just deleted the whole circle. Get it back. That was supposed to be cosine. So let me switch back to red. I was finding the cosine there. Cosine of 2 pi over 3 is negative 1/2. So back to my highlighter. Second answer, cosine of 2 pi over 3 is negative 1/2. It's the base of the triangle. Sine is the height. Cosine is the base. Tangent is like the slope of the hypotenuse, or just opposite over adjacent, but the tangent is negative root 3. Now, let's do one more for fun. Something similar. Example, find sine, cosine, tangent of 5 pi over 4. Once again, first step I always do, I always sketch a picture. Every single trig problem, I draw my circle, put my y-axis, my x-axis, and then I figure out where 5 pi over 4 is. A lot of students will take 5 pi over 4 and they'll convert it to degrees to figure out where it is on the unit circle, but you don't need to do that. All you need to know is that pi over 4 is 45 degrees. So if I count by 45 degrees, that means right here, this is pi over 4, this is 2 pi over 4, this is 3 pi over 4, this is 4 pi over 4, and this right here is 5 pi over 4. So that was me counting by pi over 4s, which means this spot here is 5 pi over 4. I drop my triangle into it, connect it to the origin, drop a line, always back to the x-axis, never the y-axis, always the x. And then here's my triangle. Now, I know that pi over 4s are 45 degrees, so I went 45 degrees past 180, which means that this reference angle is 45 degrees. Now, in the 45-45 triangle, we got root 2 over 2 for this side and root 2 over 2 for this side. Once again, if you don't have the special triangles completely on lock, pause this video, learn them, then press play again. Now, at this point, if I was teaching, I'd be like, you guys, is there anything wrong with my diagram? And then some people might raise their hand and be like, oh, yeah, you need to put negatives on some of these. We use a highlighter, different highlighter color. You guys, this side right here is in the negative x direction, and this side is in the negative y direction. So what that means is in the third quadrant, your x's and your y's are both negative. So negative root 2 over 2 and negative root 2 over 2. Cool? Now, you guys, let's go with purple. The sine of 5 pi over 4 is going to be the height of that triangle. So that means sine 5 pi over 4 is equal to, and I'll use the highlighter once again, this guy, well here, I'll go orange. This side right here. This is the height of the triangle. So sine of 5 pi over 4 is negative root 2 over 2. Cosine is going to be the base of that triangle, which is this side, which is negative root 2 over 2 as well. Should we go purple? Yeah, I'll just go purple. It's too many colors, Jolly. Reel it in. Cosine 5 pi over 4 is also equal to negative root 2 over 2. Cool. So sine is the height, cosine is the base. Tangent is the height divided by the base, the opposite divided by the adjacent, the rise over the run. It's the slope. We'll get into that later. Let's do some quick computation on what that is. Tangent 5 pi over 4 is going to be equal to negative root 2. Oh, God, that's an awful 2, Jolly. Negative root 2 over 2 divided by negative root 2 over 2. Now, you could do your multi-flip and start canceling a bunch of stuff, but you guys, anytime you divide something by itself, isn't that just 1? So that means tangent of 5 pi over 4 is equal to 1. Also, I've kind of talked about how the tangents are the slopes of the hypotenuses. I'm not sure how you say that. I'm not a math teacher. But you guys, if you look at this side that I'm highlighting in green, doesn't that hypotenuse look like it kind of has a slope of 1? It's going uphill, 1 over 1. Yeah. Let's highlight our final answers in yellow. Sine of 5 pi over 4 is negative root 2 over 2. Cosine of 5 pi over 4 is also negative root 2 over 2. And then the tangent of 5 pi over 4 is 1. All right, that was all very straightforward, which means like find sine, cosine of tangent given this angle. The last thing I want to talk about is what if you don't know the angle? What if you just are asked to find something like this? Sine of theta is equal to root 2 over 2. But then these questions will always say for like, let's just go from 0 up to 2 pi. What that part means is you might have multiple answers. In fact, we will have multiple answers that happen between 0 and 2 pi. So if I draw my unit circle, once again, every single problem I draw a unit circle, a fresh one. I don't have a cheat sheet. I just draw a picture, fit a triangle into it, bust out your special right triangles. Let's do a big circle. That's a pretty good circle, Jolly. Freehand, thank you. Okay. You guys, root 2 over 2. This part of the problem should set off an alarm bell for you that has something to do with a 45, 45, 90, because that's a side of a 45, 45, 90. So if you were to inscribe a right triangle right here, that is a 45, 45, 90, reference angle of 45. Top is 45 as well. That means this side is root 2 over 2. And that's the height of that. So you're like, yay, I figured out the answer. The answer is pi over 4, which is 100% true, that sine of pi over 4 is root 2 over 2. But here's the problem, you guys. This height of this triangle, if you were to continue around the circle, there's going to be another one over here. See how this is also a height of root 2 over 2? In fact, at this point right here, like if you flip that triangle into quadrant 2, you're going to get a second triangle that also has a height of root 2 over 2. So counting by, let's do a different highlighter color, root 2 over 2, no, excuse me, pi over 4s. This is 1 pi over 4, 2 pi over 4, and 3 pi over 4 right here. So, guys, another answer, 3 pi over 4. Because this is another triangle with a reference angle of 45 degrees where the height is going to be root 2 over 2. Now you might think, well, what about the ones that happen in quadrant 3 and quadrant 4? Well, like they're close to root 2 over 2, but if I were to jump down to this guy right here, the height here of this triangle is not root 2 over 2. It's negative root 2 over 2. So this one, let's use red. This is not one of our answers because it says it has a positive root 2 over 2, not a negative root 2 over 2. So you don't have to worry about that. Our two answers are 3 pi over 4 and pi over 4. So theta equals pi over 4 and 3 pi over 4. And we're done with that problem. Any questions? Okay, moving on. Let's knock out a couple more. Let's do a cosine. Cosine of theta is equal to negative 1/2. And let's say our answers are going to be between 0 and 2 pi. Full circle around. Once again, I always draw a unit circle. Put your x and y in there. Now, negative 1/2. This should set off an alarm bell for you that that's a side of the 30, 60, 90 triangle. In fact, it's the side that's across from the 30. Oh, Piper, come on. I'm making a video here. You can't whine like that. Don't give me that look. It's across from the 30. It's a 30, 60, 90. So, the fact that cosine is negative means that it's going to happen somewhere on, oops, I want a highlighter, the negative part of the x-axis. So, negative 1/2 is the smaller side of the 30, 60, 90 triangle. So I think it's right here. Yes, where this reference angle would be 60 degrees and the top angle would be 30 degrees. Now, where the heck is that in terms of radians? Well, let's think. It's when you count by pi over 3s. Like, I'll use a different color here. So this is 1 pi over 3, and this is 2 pi over 3. Now, if you go 2 pi over 3, that means the base of this triangle is going to be negative 1/2. But once again, the theme with all these problems is there's multiple answers depending on how far you're going around the circle. If you take this triangle and you flop it down into the third quadrant, there is another triangle that has that same base right here of negative 1/2. Excuse me. I don't have COVID. That means you got to figure out what that is in radians. So let's use a highlighter. This was pi over 3, 2 pi over 3. This is 3 pi over 3, which means this is 4 pi over 3. So those are the two spots where you're going to have a triangle with a negative 1/2 base. That doesn't happen in these quadrants because anything in those quadrants would have positive cosines. Negative cosines only happen in quadrant 2 and 3. So final answer, let's go purple. Theta is equal to 2 pi over 3 and 4 pi over 3. Let's do one more. Then I'll get out of here. We did a sine, we did a cosine, you guessed it. Find tangent of theta is equal to negative root 3 over 3. That shows a hard problem. Okay, here we go. For the interval 0 to 2 pi once again. So let's draw the circle. Now, there's a couple things you should think just by looking at the problem. The first thing I think of is that it involves a root 3. I realize there's also a divide by 3, but we'll get to that. The fact that there is a root 3 in there makes me think it has something to do with a 30, 60, 90. The other thing that I am thinking is that because it's a negative tangent, if you think of tangents as the slopes of those hypotenuses, where you get negative slopes, like the hypotenuse is going downhill, would be in quadrant 2 and 4. Let me just draw in what it would look like if you did a triangle in quadrant 1. Like if you had a triangle right here, do you guys see how this side is going uphill? It's like a positive slope this direction. So we know that that tangent would be positive, but our tangents aren't positive, so let's go and doesn't happen here. Also doesn't happen here because if you were to draw a triangle over here, you would get negative divided by negative, which means you would get a positive slope as well in this direction right here. So it's not in quadrant 1 or quadrant 3. It's definitely in quadrant 2 and 4. Now, negative root 3 over 3, that means there's a 30, 60, 90 that fits into this. So it's either where the reference angle is 60 or the reference angle is 30. You could try both of them. Let me think. It's going to be negative. Well, yeah, you could try both of them. Let's just try one of them and see what happens. Let's say that you did a reference angle of 30 degrees, which looks something like this. That means this side would be positive 1/2, and this side, let me just clear out some of this junk here. And this side would be root 3 over 2. But then you got to think, are either of these negative? Yes, the one in the negative x direction is negative, so negative root 3 over 2. But then this guy right here, the 1/2, is in a positive y direction. So it's good to go. It stays positive. Now, if you were to take tangent of this, tangent would be opposite over adjacent. So let's just try it and see what happens. Tangent of theta. Oh, you guys, we never said where that is on the unit circle. Let's see. That's counting by pi over 6s. And I'll use a different color for this. Here's like pi over 6. 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. 5 pi over 6. So if we were to take the tangent of 5 pi over 6 with this reference angle of 30, that means the opposite side would be 1/2, and the adjacent side would be negative root 3 over 2. Now, the algebra there, the top fraction stays the same, and then you multi-flip the bottom into 2 over negative root 3. The 2's cancel out, and you get 1 over negative root 3. Now, sometimes IB cares about this, and sometimes IB doesn't, but this is definitely a situation where, you guys, we have to rationalize the denominator. That radical in the denominator is a problemo right now. So you got to blast this guy with a root 3 over root 3. Which is allowed because it's a giant 1, so I'm not actually changing it. And then you get a root 3 on top, but then root 3 times root 3 is root 3 squared, and the square and the square root cancel each other out. So you get negative 3 on the bottom, which is the same thing as negative root 3 over 3. You guys, OMG, we found it. See, this negative root 3 over 3 in purple, that's what we were looking for. So, that's an answer. That means theta is 5 pi over 6. But, you guys, it is not the only answer. Let me show you how to cheat the second answer a little bit. If you take the hypotenuse, which I'm highlighting in purple here, and you just kind of extend it into the fourth quadrant, so like just keep going with it. Do you guys see how both those purple lines would have the same slope, which means they have the same tangent, the same opposite over adjacent? This triangle is the other answer. So I was counting by pi over 6s? I mean, you could keep counting, but I guess the way my brain thinks of this is that a full 2 pi, like to go the full way around, 2 pi in terms of pi over 6s is 12 pi over 6, which is the same thing as 2 pi. So if you back it up 1 pi over 6, that means that this spot right here is 11 pi over 6. So that triangle will also have a reference angle of 30 degrees. It'll have an opposite side of negative 1/2. That's bad. Oh no. Oh no. That's fine. Oh no. This side is going to be negative 1/2, and this side is going to be root 3 over 2. So then when you divide negative 1/2 by root 3 over 2, it's very similar algebra steps to what I just did, and you get negative root 3 over 3. So final answers. Let's go purple. Theta is equal to 5 pi over 6 and 11 pi over 6. Good to go. All right, you guys, we're definitely getting into the thick of it with trig. I think next week we're going to start talking about sinusoidal graphs. My favorite, one of my top 5 favorite math words, sinusoidal, right there. It's really fun to say. Catch you next time.